Welcome to Thonium 9's first Sunday session 2025. We are a small business providing integration services for Tridium Niagara, Schneider, Crestron, KNX, and we are a British Controls Industry Association member, a CDM member, and a member of the Institute of Engineering and Technology. We also have our Cyber Essentials certification, detailing our security practices in depth. And what we're here to do today is to talk about the Universal Device Management Interface. So approximately 6 years ago, I had the privilege of working with Google to develop their DeepMind S2 project for the cloud device communication. And we developed a framework called Device Automated Qualification Framework, which is now been deprecated. And out of that came the Universal Device Management Interface. Now, the Universal Device Management Interface is a methodology of creating a shadow device digital twin of a real-world device in the cloud for performing fault detection and diagnosis and data analytics and connecting up to dashboards and 3D BIM models, and then also providing actuation commands from mobile phone applications or desktop applications for engineers. So if you ever want to know in more depth than what I'm going to go into now, you should visit this website, github/sdn/UDMI. And there's some really great documentation around how to implement the UDMI schema into a building. But that's incredibly complex and an awful lot of work to understand from the initial go. It also provides a lot of different functionalities around certificate rotation and onboarding devices to cloud systems. It also provides validation of the metadata, the state data, and the point set telemetry data that comes out of the devices. So there's tooling in here that validates the JSON payloads that you've created inside your control system, be it a Tridium Niagara, an EasyIO, or a Delta Controls, or a Distech controller. But today we're going to focus on the Tridium Niagara because that's one of my personal favorites. There's also something that comes along with this which helps you name devices in buildings correctly and in a standardized format, and that is the building device naming specification, which within here there's a model of how you should name your devices. So if you're going to onboard a fan core unit, typically it's an FCU. If you're going to onboard an air conditioning unit, then it's a ACU, and they hold a register that's actually kept up to date in here. So, you know, an air conditioning unit, ACU, an air handling unit, this is a rooftop version, so it's an RTU, a variable air volume box. So you would come in here and then identify what asset you're going to onboard so that you could onboard it with the correct name. And then also Google have invested a lot of money in consultancy and developing this over the past at least the 6 years I've been involved with it, and a lot of other people before that have been involved with it. I worked closely with a guy called Cherub Herring very early on, and Kathy Farrington. They were the client. I worked as a MSI underneath the Excel Redstone banner at the time. John Dente and David Salisbury were our leaders in that business, and I was the principal software engineer. And fortunately for me, I had engineers like Oliver Barker and David Lee that would disseminate information about BMS World into my software skills so that I could build it correctly. So the Digital Buildings project is a really useful website, and you should explore these lessons when you get a chance, because it really helps provide contextual information to what we're trying to achieve. And then inside the Digital Buildings repo on GitHub, there's actually a telemetry fields YAML file which dictates how you should name a point. So lots of different BMS companies typically have their own methodologies around point naming, and when we want to apply machine learning or standardized dashboards to systems that we want to scale, then it's great if we all work off of what we call an apple in simple terms. So this is a great place to come and ensure the name that you've selected for the point of data that you're going to transmit to the cloud is correctly named. There is also a Google Groups UDMI discussion group which used to occur on the interval every 2 weeks, but I think they've now scaled it back to monthly, and there's 175 users currently in the group. That usually about sort of between 30 and 50 people join each time, and it consists of Trevor Perring going over his latest list of hopes and dreams and complaints from people that have struggled with the framework. So that's sometimes really good to get involved with. So now today I'm going to go into my Tridium workbench and just explain in simple terms how to map points into the Universal Device Management Interface framework so that we can send the telemetry data to the cloud in a coherent, contextualized manner. So from this particular air conditioning unit, we have here at HQ on test. So we have the Boolean on-off value. We have a numeric set temp value for writing back temperatures. We have a current feedback room temperature value. We have a fan speed enumerable point, and we have a mode enumerable point. And from that, to send this data